Oh, number 23?
I'm just confused with the x is greater than 0.
Oh, why the book had that?
Because you had to find the domain.
Okay,
Yeah.
the first thing, you had to do the domain.
Hi. Can I steal a calc book or are you using it?
I'm using it.
Okay, never mind. I was studying for you.
If,
What page is the homework? I'll take a picture of it and text it to you.
if Dr. Mendelson is in the faculty room, I think there's a calculus book above the cabinet above my desk. All right, so what's the rule for,
I did log power rule, right? Instead of the first.
the log power rule?
I'm putting the negative 1 in front.
Ah, okay, so instead of applying the chain rule, is that what you're saying?
I guess. Well, when I did it the other way, it didn't work for me, and then I realized that I could do that and it worked.
Yeah, you can do that, because,
You can also do it just regular log rule at the 1 divided by x and works too.
so it should work either way, because if you use property of logs, if you have a power of -1, right, the power rule for logarithms, you can move the power to the front. Remember, logarithms are exponents, so when you have a power raised to a power, you multiply them. That's why that rule works. Does that make it a little bit easier to do the, so what is it? It's
Maybe I'd like
negative?
to see it the other way. 'Cause I don't
You
know
want
if
to
I
see it
did
the other
wrong.
way? So it's -1, and then what do we put?
Excellent.
X ln 2.
But if you don't,
I mean, that's just 1 over x times, and then it's natural log of the base, which was 2. So you want to see the other way?
yeah.
So if you kept it as x to the -1, did anybody do it that way?
I did it as 1. I did it as 1 over x.
Yeah, I did that way.
Okay, so what if you kept it as 1 over
This
x?
one I got x to the -2 and I got really confused how to do it.
So what would that look like, though? It would be 1 over
X to the -1.
x to the -1, which is 1 over x,
Yeah, divide that.
times ln of 2 times the derivative of x to the -1, which would be -1 x to the -2. So what do we end up with? There's a -1. Well, if the x squared goes to the bottom, that's going to cancel out the x to the -1 to give us, do you see if I move that down here, that'll be x squared. So x squared times 1 over x will just give us an x.
Got it.
Make sense?
Yeah.
How it says x it has to be
Because that's
Oh,
the
just
domain.
part of the domain.
what, like, so if x is a negative,
Right, you can't have a logarithm of a negative number.
but
But
for the derivative you can code because it's not a logarithm of a negative number.
No.
Let's say it was x is -5, -5 times ln of 2.
You can't have -5
For x.
for the derivative, or you have to go back to the original function. You can't have a derivative of negative. So if it can't be negative, honestly, I'm not concerned about x greater than 0. I would assume that x is greater than 0 based on the original function. That's fine. Okay with that?
Yeah.
All right, then 27, there was a question on that?
Yeah. Yeah.
So it was y equals log base 10 e to the x, so that's what we call the common log, right, with a base of 10. So how would we apply this? This is going to be 1 over e to the x times ln of 10. And then the whole thing gets multiplied by the derivative of e to the x, which is just, what do we notice happens? These cancel, so we just get 1 over ln of 10. Okay with that one? Number 29. So at what point on the graph of y equals 3 to the x plus 1 is the tangent line perpendicular to y equals, no, I'm sorry, parallel. I was looking at the other one. Parallel to y equals 5x minus 1. Well, what's the slope here? 5. Yeah, so let's do the derivative of 3 to the x is going to be
3x times
to ln of 3
Yeah.
plus 1, or plus 0, excuse me, because you derivative of that. Then what?
Wait, why did you
Said
do
it
that?
equals 5.
That's what I meant.
Oh.
Sorry. Then what?
And you.
Divide by ln.
So divide the whole thing by ln of 3 on both sides.
And you ln both sides.
So ln both sides.
And move x.
So ln of 5 over ln of 3 becomes x times 3.
Ln. What's up?
I know, and I didn't even take the PSAT. So it's x ln 3.
Yeah.
Yeah.
And then divide both sides by ln 3. And you get 1.379.
Yeah. But it's weird.
And it says, oh, it says what point. So if that's the x coordinate, right, so you're going to take this, plug back in here to figure out the y coordinate. So 3 to the 1.379 plus 1 gives us 5.5555.
Well, not when you plug it in like that.
It doesn't work?
You get like 3.499 or something like that. But then when you you get something weird. But then when you plug it, if you don't round.
If you don't round.
And then you plug it back in, you get 5.
So if you get,
1.379, it's not that.
so
it's
it
not-
doesn't come out that way, so
No, but the book gave you an answer as if they didn't round, even though they told
they
us
usually do.
they rounded.
And then you said this plus 1 won't. Does it give you close?
Close-ish, like.
550, yeah, it would just be 55,
Yeah,
no,
I guess.
549. It's a
But
little
then
bit
I just
off,
didn't
it's
round
2
it,
hundredths
yeah.
off. Generally speaking, if you get a decimal for, remember how I showed you to store the value? It's a good habit to get into, just storing that value as x or any other variable, and then just using that value over again. Storing them? So let's say we have, let's see here, it was ln of 5 divided by ln of 3. And I want to divide that by ln 3. So you have this store button right here. And then I'll just store it as x. And then press enter.
So you press store and then X and then.
Yeah, and you could use alpha, any of your variables. So then when I do that, it would just be 3 to the x plus 1, and hopefully that comes out to 5.551. It does. That's all. So they just didn't use the rounded answer.
Feel bad for whoever has to do the solutions manual test. What about
They're usually like graduate students.
Oh.
They have to put it on the computer, it's not.
You get paid?
No, they don't. I don't think that they type them up.
But then how does it get into
It's a good
the
question.
typing format? Stenographer?
Yeah, well, there's just like the programs that I use, like to write your tests.
Photomath. What?
Not photo. Math type is one.
Do you get paid for doing it for graduates?
I don't think so. Maybe, maybe not. If it is, it's very little.
You don't get paid for doing it.
We get credit.
It's fun. Okay.
It's fun. Okay.
We don't even do all the
You're
problems.
joking, right?
We don't even do all the problems in this book. And they have to do every single
You don't think it's a
one.
little bit fun?
Well, they probably have
They're good
multiple
at it.
people to.
Okay, well, if you're good at it, then the more you practice, it gets easier and easier. And trust me, they make plenty of mistakes. We find plenty of mistakes in the book. Okay, what do we do first?
Yeah, L on both sides.
And the reason we do that,
Okay, so then you can pull down the power.
good, so ln of y equals ln of x
times ln x.
times ln of
Here's where I got
x.
stuck.
Now we're going to do d dx. Remember how I had like the step by step? Now some of you might have noticed that that's ln of x squared. So you could do the chain rule there, or you could just do product rule. You'll get the same answer either way. Do you understand what I'm saying for that?
Wait, can you go to scroll?
Wait, what do you mean?
So there's two different ways we could write this. Not ln of x squared, but the quantity of ln squared.
Yeah.
The whole thing.
What do you product rule book?
Or you could write it, another way you can write it, just like with logarithms, you could always put the 2 right here.
Oh, that's what I did wrong.
So you don't do product rule.
No, you can do chain rule if you want. It would work out either way.
And the chain rule is what we.
I would probably write it out the one on the right, but you'll get the same answer with product rule.
The chain rule is what we learned yesterday. And the chain rule of LN. Or is it different?
Yeah.
Oh.
Did we do chain rule of ln? I think so.
So 1 over u and then du dx.
Right, but this is a little different because this is an ln of x squared. This is ln squared of x. So it's actually the chain rule, then you do the derivative of that. You do the exponent to the front. Let me show you
Yes,
here.
please.
So this is 1 over y dy dx,
I got that.
okay? And then remember, think of this as ln of x squared. Just like when we would write sine squared of x, I said it's really helpful to write the sine as sine x and then the whole thing is squared. So the 2 moves to the front, keep the inside the same, right, to the first power, times the derivative of the inside, which is 1 over x. Does that make sense?
The derivative of, okay.
So we get 2 ln, sorry, 2 ln x over x, and then we want to multiply that by y. And then go back to what was y originally equal to? It was x to the ln x. Cancel nothing.
Wait.
I
So
mean,
is that how you want the answers?
yeah, the only thing they did was they just combined it all into the numerator. I think they wrote it,
I think they just
they
did
did
y.
2
I think they
x to
substituted
the
that.
ln of x times, no, they didn't, no, this is how they have
Oh,
it.
yes, they did. Never mind.
Since it's divided by x, you could say that it's 2 times x to the ln x quantity minus 1, because it cancels 1 from that.
You could. I wouldn't. But you could. This would be like a multiple choice problem anyway, so they would only have, you know, they're gonna have certain ones there and you have to, if you didn't, maybe you got to this point and you would just look at the answers and see how they had the solution. So if they had it with the, to the -1, then yes, you would have to do that. Okay, that was 47. And then 51. What was, oh, spread of a rumor. A rumor. And it was just 51.
Yeah, I totally thought it was slow until I reread it after it, but it didn't really matter. Like, oh, that's fun. But it wasn't.
It wasn't.
It was a little questionable, but that's about it.
I wouldn't even give him that.
Did we get A? A was fine.
Yeah. I always forget when it says rate to do the
Initial?
The derivative.
I just thought of who would spend time calculating the rate at which a rumor spreads.
Gossip tweets.
Yeah, no.
Wait till we get to the rest of the application problems. There's all kinds of weird things they bring up. Like one of the problems we looked at last year was there was a baby elephant at the zoo and they were taking
The derivative of it.
no, they were taking people are filling out names that they wanted to choose. They had to vote.
Like a vote.
And they wanted to see how quickly the votes were being cast at certain hours. And I'm thinking, like, what is this? They just come up with weird, random problems. It's just,
Why don't they come up with examples that would actually be used
they do.
online?
They do both. But they need to have practice with all different
Formula-
types of problems.
So basically formulas that by doing this, they're admitting the formula will never be actually used in real life.
Hey, you never know. Rumors being spread. Look at this. How fast is the rumor spreading after 4 days? So that's, right? Did you plug that into your calculator?
Yes.
And what did that look like?
52.
So, did you just use the math 8?
Yeah.
Yeah.
Okay. So math 8.
But I guess it would be easier to graph it and then find it at 4.
Right, because
then you have to do for the next
you have to
one.
do when is it spread at a maximum rate. It turns out to be similar to the
And then you
one
have
we
to-
did in the
and
notes.
Then you have to graph it anyway, so you have to put it into your calculator twice. That's just
Can you do it from the ground?
You have to graph it?
We could.
Yeah.
Because for part C you have to graph it.
Value of
But you could do the same thing for B. You could graph it. You could just do it and find the value at 4.
Well, let me just write out.
What's the point of writing out the original equation?
It makes
Okay, so why do I write out the original equation first? I want you to get into the habit of putting the first equation in first, because when we get to later parts where we have to apply the original function, the derivative, and sometimes the second derivative, it's good to have them all in there. Do you need to do it? No, but I happen to do it because it's good practice for what we'll be doing in the future. Okay, so, oops, not tangent.
I did it like the long way where I wrote everything out.
Really?
I got negative. Is it like X? Is it
You mean you didn't put Y1?
like what? No, I didn't plug it in. I wrote everything out. Like I didn't use the calculator. I did it by hand.
Hmm.
And I got the same answer, but I got negative.
Let's see.
What's most intriguing about the person?
Their
gum has truth or dare.
The gum has truth or dare on it. It's the most ridiculous things.
That was bad. Okay.
Yeah, sorry.
It wasn't, it's not aerodynamic.
Okay. So the
I'm
red.
in the PSAT mindset.
Got it. The red one. The good thing we're not doing anything new.
Yeah.
This is the maximum that we're looking for, which happens to be at 4. What did we get for this?
52.
Yeah. So if I want to do the derivative, you could just do the value. Just make sure. Oh, does it show which one I'm on?
Yeah, I don't know.
I don't know which one I was on to begin with. Oh, it just gave me that one.
But if you were to switch it 4.
Yeah, I need to switch which line I'm talking,
Yeah.
which one I'm doing the derivative of. But the first one, that comes out to what, about 52?
Would you have to hit trace and then move it down and then it'll work?
Yeah. And then C, we saw that it was at 4, so. Okay.
There's a C.
Yeah. It's the same thing as the notes. I'm trying to remember if I put one of these on the test.
Yeah, please don't.
It's
Okay.
an easy
They're not
cal-
hard.
It's
It
an
is-
easy calculator.